Yes.
Okay. All right. So this is the Ubuntu TechHive website for this group. All the content have been posted here. So if you, I'm sure the link is in the chat right now. If you want to open and go through this while I present, that would be great. Also, I posted the same. We posted the same content in the GitHub repository here, which I'll be using to step through the presentation. On GitHub or even on the website, the content has been translated from English to French. Sorry. So you have the English content and followed by the French translation throughout the presentation. So at this point, we can state the goals here. The main goal here is to understand the fundamentals of natural language processing and how it is used in many of the text generation tasks, such as the classification task, translation task, text summarization, or text generation, and other tasks. We are going to also look at two Python demos. The first one is to show the text generations for classification and summarization. There's a third one for translation, which is now working on our Amazon AWS platform. But I have it locally, so if we have time, we can also take a look at that. In order to get into achieving these goals, you first have to know what a transformer is. You first have to know what a transformer is. There is a document that a group then working at Google and State of University of Toronto published. They published this document called "Attention is All You Need," and this paper talks about how the transformer architecture should be designed or is designed. So guess we can. So on a high level, the transformer, you can think of it as a machine that really understands text. So when you send that machine, the transformer model, when you send it text, it's able to take that text as instructions and produce what you're asking it to. So that's on a high level, that's what the transformer does. Give it my cursor. So I'm going to move down to the architecture. We can take a look at the architecture here. So this is the transformer architecture. So the architecture, there are two parts of the transformer model architecture. The left side is the encoder, and then the right side is the decoder. So what this does is that when you pass in your prompt, your text or sentence, it goes through the encoder, and then it goes through some neural networks, and then its output goes through the decoder, and the decoder also does some stuff in the neural network and then outputs a response. We're going to go into much detail than that. So let's focus on the left-hand side. You can think of the encoder as a stack of let's say pancakes, right? But instead of pancakes, it's made up of. So let's say this your pancake. Within that pancake, there are sub layers. So there are two sub layers for the encoder. The first one is the feed forward neural network, and then we have the multi-head attention neural network. So what happens is that when you pass in an input, a sentence, there's a module called the tokenizer. So the tokenizer, normally the transformer needs the input in numerical form. So the tokenizer will take the inputs and then tokenizes, it does the tokenization. So which is basically chunking your sentence into words, for example. There are different types of tokenizers. We have the character tokenizer, we have the word or phrases. So we can just focus on word tokenizer. So let's say you send the transformer a sentence which has 5 words in it, in the sentence. The tokenizer will just chop the sentence into 5 tokens. And those tokens are sent through the embedding model. So what the embedding model does is going to convert each of the tokens into numerical form, into numbers, and that's the input that the transformer understands. So once the sentence is passes through the embedding model, and the text is the embedding model generates the embeddings. So the output of the numbers is called embeddings. That embeddings is sent to the multi-head attention. So at the same time, the positional encoding, what it does is to encode the positions of each word within the sentence, because the transformer model needs to understand each location or each position. The words, it needs to understand which positions the words are in within your sentences. So once the embeddings is sent to the multi-head attention. The multi-head attention, you can think of it as an expert of linguists. So let's say you have 10 linguists, and then you give them the input to analyze. So each of the linguists will analyze the data, the input, and come up with their own insight. So the multi-head attention behaves the same way to understand the context of each word within your sentence. And the output of that, there's something called, I think it's called, I don't have it here, but give me a second. There's something called a residual connection. So that actually sends the input, because at this point where after the multi-head attention does its outputs its data, at that point it doesn't know the full sentence that was passed into. So what this loop does is to send that your full embedding sentence as part of the data that comes out of the multi-head. And that is normalized. So the normalization is normally the parameters, the number of parameters that comes out of the embeddings. Let's say it's 512. This normalization layer makes sure that the outputs from the multi-head also is it's also 512. If it's not, then it does some padding to the output to make sure that the data matches what was sent to it. Now, this data is then sent to the feed forward. The feed forward, what that is, you can think of the feed forward as basically is the layer. It applies some linear transformation to the data that goes through it, and that is also normalized. So once it goes through that once it comes out of that, so that was the output of the encoder, and now that output is sent to the decoder. The decoder also has the same similar neural network in them, but an extra one. As you can see, there are three. So this is one. There's an extra multi-head attention that is added to the decoder. And that also goes through similar process as described. And then finally, when the text is, the output is generated here, it goes through this linear soft function. So this is a mathematical function that produces some probabilities of the output. So the probabilities, let's say an output sentence, there may be 5 output sentences, and each one of them will have a corresponding probability number. So the highest number will be the one that the user will see, basically. For example, if you type something in ChatGPT, what comes out is the one with the most, the highest probability based on what you've based on some temperature and all that. We're not going to get into that. So basically, that's how this is the architecture that the folks at Google released in 2017, and that this is at this point there are other companies that took this architecture, like OpenAI, Amazon, Facebook, and a whole bunch of other companies took, and even individuals are even building models based on this architecture. Is there any questions here?
None in the chat. Nothing in the chat. Continue.
Okay. So the pros of this architecture is that initially there are existing neural networks, like the recurrent or the convolutional neural networks, that also generates text, but they were generating, those systems generate text in sequence, so you cannot sequence, and it takes a lot of time to even train such a network. But with these neural networks, the reason why you can do things at scale is because you can send these tasks that the transformer does into different accelerators, GPUs. So these GPUs are super fast components that will process the data, where the multi-head that does its work. So all these things are happening on the GPU. That's way faster than what's happening on the CPUs. So now we can generate things more faster. The link, this paper, I'm sure it's in the chat. You can review. It's about 15 pages, not that much. About 5 of the pages are like appendix. So you can go through this and understand how the architecture is designed.
Kofi, do you know how long like training one of these models can take?
It all depends. There are different models, right? They have some that are 1 million. There are others that are 1 billion. There are 7 billion LLMs. There are 175 billion LLMs. So it depends on how big the model parameters are. So the higher the parameters, the more time and resources it's gonna take to train the model.
And I'm sure all these cost a lot of money, especially in terms of computer power, right? Because like one person cannot, like, if you don't have perhaps like millions of dollars, you may not be able to train like a model like ChatGPT or Bard or things like that.
Yes, and the training sometimes take months, right? So once you run the process, it's gonna take like, let's say, 6 months for a model to be trained on large sets of data. Even setting up these programs locally without training, I'm just setting it up and then prompting it and expecting a response. It eats up all my CPU. It's very slow to do this locally. So you rather have to run this on the cloud platforms, Amazon, Google, Oracle.
Is that why NVIDIA is almost worth $2 trillion right now?
Yeah, definitely. NVIDIA is in a very good spot. If you look at their history, what happened during Bitcoin, the craze for Bitcoin, it was all being run on NVIDIA GPUs. And now there's another wave for transformers and model training and all that.
Got it. Okay. Thank you.
Excuse me. I have a question in general.
Sure.
Yeah. So I hear most of the time that we need a lot of computing power in order to train a model. So that's how you call it, right? So, but how come certain technologies, they pretend that you can run your local LLM on a small computer and they pretend you'll have the same performance? How is it possible?
Well, there's a group that is more focused on small LLMs. So, for example, instead of the billions of parameters, they may have, like, let's say, I don't know, 50 million parameters. And with those small LLMs, yes, you can run them on your local. Even the 7 billion, I can run the 7 billion on my local machine, but it's slow. The performance is slow. But as far as performance, I know they do benchmark against the bigger ones and try to make the argument that you don't need the large LLMs. But again, when you get into the technology, the larger the parameters, the more robust the LLM is.
Yeah. Okay, I see. Thank you.
Yeah. Also, another thing that they do to help run the models locally is that they decrease the precision, because the weights of the models are represented as floats, so they decrease the precision of that float so that it doesn't take as much memory, and then it can fit into like a personal computer.
Okay, so if I understand correctly, that means performance-wise, they're not the same. Because I'm pretty sure everybody saw some videos where they say run your own chat GPT on your computer or something like that, right? So because I was always a little bit confused. That's if we can run it on smaller computers, so why bother spending millions or billions of dollars training something like that on larger computers?
Well, I mean, with less precision, it's not gonna provide as good of results as the full model. So they decrease it so that when it fits and they feel like it's good enough, they use it, but it's not perfect. To have the best performance, the actual model is better with more parameters and high precision.
And it also based on your use case, right? So probably the smaller models will work perfectly in certain use cases, and for large corporations, definitely they will not depend on the small LLMs because they need more compute power.
Okay.
Alex, do you have a question?
Yeah, I was just wondering, as far as like cloud providers to, train models, what are your go-to when it like I've used Collab a little bit, but what are some of your other go-to like providers as far as like training a model that, in the cloud, instead of have it locally, because obviously, we're not all made up of NVIDIA GPUs here.
Yeah, so there are several of them. AWS is a good one, and then on AWS they even have all the models already pre-trained on there, so you can just grab and use or even train. And you have other services that in terms of scaling up on GPUs, AWS is a go-to one. Of course, Google Cloud, and even Oracle Cloud, and other cloud vendors. So for go to cloud vendors, I'll say AWS or Google.
All right, thank you. Oh,
Sure.
yeah, thank you, Benjamin. I've looked at SageMaker. I'm also I've heard good things about Bedrock as well.
Yeah, with Bedrock you can connect through using the Boto 3 SDK, and most of the things that you do in Bedrock is more on the developer side, to use APIs to connect to these MLs models on Amazon, on AWS. So it's mainly using the APIs to communicate that way. Yeah, so Bedrock, SageMaker is where you have to focus on.
Thank you.
Sure. All right. So as mentioned, there are several companies that are creating these transformers for us. So once these transformers are released, as far as open source goes, most of the models you will find on huggingface.co. So on Hugging Face, as you can see here, they have the models, they have the data sets, and then they have the transformer libraries that you can use to do your programming. So for the models, we can get into that quickly. So there are different modalities, meaning you want to do text to image or image to text or voice to text or vice versa. So those are the different modalities. Our focus is under the natural language processing. So we're going to take a look at the text classification, summarization. Hopefully we can look at the translation, and then using RAG, retrieval-augmented generation, to see how that is going to benefit implementation. So we have audio. So for example, if you want to find an LLM for text classification, we click on text classification. There are 49,000 of them. So this thing are being generated or created super fast. So for each model has a model card. All right, a model card basically states the requirements of using this model. All right, and sometimes it even gives you the how to write the code. Right, this is Python. How to use the transformer pipeline to instantiate the model, the tokenizer, and then the model. And then based on these two parameters, you can use them in your Python code. So all the models here follow the same process. So you click in, and then you have information about the model. Some of them will even give you a boilerplate code. You can run this on your local or on your server. So some will have the code in Python, PyTorch, and mostly I've seen Python and PyTorch. Okay. To know more about the transformer library, you can just go to the documentation and go through transformer, and then you can read through all that. Any questions, sir?
Would you say like all this material is approachable in terms of like understanding? Would you say that?
Yes. Yeah, definitely. I mean, I learned most of what I'm teaching here. What I'm presenting today, I was on Hugging Face here, trying to understand the code and all that.
Okay.
Some of the code you're going to run into issues, of course, because these were posted like months back and things have changed. Library names may even be different. So once you run into issues, you have to dig through to find out what the current code is.
Okay.
All right, so that's for transformers. Data sets, we can do another presentation on that. So that's a whole area to discuss. And they have some in JavaScript if you're into that. So all these things you can, dig into it and learn specifically. So one other tool that will be helpful today for our demo is called LangChain. So LangChain is a framework. What the framework does is to connect the LLM, the transformer model, to a retriever. Let's call it a retrieval model. We're going to get into that, but mainly this LangChain framework tool will help you do that connection. So you have a model, and then if you need external data to form your prompt, so you use LangChain. You take your input prompt, and then a retriever that retrieves data from a Vertex database, and then you join the results into with your prompt query or sentence, and then you pass that to the LLM for the LLM to give you the output. So we're going to get deep into that. This is a quick intro on LangChain. So these are the core libraries that you're going to use if you're using this technology. Any question here?
The one comment that I want to make is LangChain is pretty popular in terms of a framework being used. I see a lot of companies actually using it to build their RAGs. So could be a good investment to learn this. So that's my comment.
Yeah. Okay. So at this point, I think we can get into our first demo for text generation.
Hi, Kofi. Is it possible to increase the font a little bit?
Oh, sure.
So,
is it better?
Yeah, it's better. Yeah, thanks. Oh, actually, maybe a little more. Yeah, it's better. Yeah.
Okay. All right. So our first application here is the text generation. I'm using 3 models here, right? The one from Facebook, the BART large, mainly that's how they call it. And then there's another one called from Google called the Flan T5, and they have different sizes, but I'm using the large. I think this may be 7 billion or something. But for now on AWS, I'm not able to get this programs installed, so I've commented them out from this code. I have it run. We can take an example on my local, which is slow, but when we have time at the end, we can run from my local. So we're going to take a look at the Facebook model, and then, well, there's another one from Facebook called Bratler's CNN. So this program utilizes these 2 models. So what is happening here is that you first have to import the transformer. So again, it's a library that we saw in Hugging Face, right? Installation. Yeah. So it's a Hugging Face library. This place is too bright in my eyes. Where am I? So it's a Hugging Face library. You import that, and then you import the pipeline. You install that, and then import the pipeline. What's happening is the pipeline abstract a lot of the coding. So when you pass it 0-shot classification, This is an example of prompt engineering. It's saying that, give me this pipeline for a classification model. This model, I do not want to do any prompt engineering on this. Just a straight shot, right? That we're not going to provide it any examples for the model. So we're just asking a connection to the model, and then we're going to prompt it. And then the second one is the same way. It's asking for a summarization model. And then we're passing the model name from here, which is this one. So it knows, the pipeline knows to go into the library to pull the right model for our use. And I have these functions here. This first function here does take some inputs. So the sequence is what you ask it, and we have some labels. The labels are here, whether we want to classify the text, the sequence to classify, if we want to classify that as positive, neutral, or negative. So based on what the model returns, we're going to display that here on this line. And then we move on to, we're skipping the translation, as I said. We're moving on to the summarization. The summarization is the same way. We have the summarizer pipeline here. We're passing it our prompt text, the maximum length and minimum length is set here, and then some do sample. Don't know what this is, but we can go back and look at the definitions. And then we're returning the summary text from the summarizer, and then we're printing that text over here. All right, so I'm going to reconnect my kernel. Should have died right now. So let me go back and run this right now. Did it do something? Let's see. I'm running this here. Sometimes it's fast on AWS, sometimes it's slow. I've noticed that then.
Yeah, it's kind of like flaky. So.
It says it's busy, so it's doing something. And all this code is on the GitHub. So if you have the Ripple link, you can go in. So now what we're looking at is this text gen program on GitHub. You can download this to your local and install the libraries. Still going. Yeah, that's unusual. So let me restart. There are any questions, guys? You can ask now while we wait for the
Yes.
system.
My question is more on SageMaker. I've never really used it. So, are you able to kind of change the compute power on it, or do you get what you get basically?
No, they give you a range of. Let me log in here. They have tens of different compute powers.
Okay.
So, for example, we are in SageMaker right now. Under the Jumpstart, so you click on the foundation models. So these are the models I was saying that is on Amazon already, AWS. So they have the Llama 70 billion. They have one for 7 billion. Yeah. This one instructs light on mini instruct is 40 billion, 13 billion. So they're different sizes. So you have to pick and choose.
Right.
I've run this on my local, the Llama 7 billion. Super slow. And then go ahead.
I was gonna say, is this free to use or do you pay?
Come again?
Is this free to use or do you have like do you pay or?
Yeah, so you're running this on Amazon, so definitely you're paying for the service.
Okay.
Yeah.
It scales with your pocket. On your laptop, it's free, but once it's on Amazon, it starts to scale up.
Sure.
Yeah. So, for example, if you want to use the Llama 7B, now this takes you to the card and all that. I think yesterday Ben and I was here. Let me give me a second. Let me see whether this is back.
You probably have to run it again. It looks like the kernel died.
The Jumpstart should take you to where you can select your compute power. That's where I'm trying to get. Open Notepad. We can get back to that. I don't want to lose.
But it's also possible to see how the selection is made from the GitHub. That we have there's a script in the repo to basically script up set up the SageMaker environment. I think it's in the infra folder.
Yeah, I need to go back here. There you go.
Yeah, maybe can you zoom a little bit? It's hard to see.
What?
Okay, so there's the Gen AI infra stack. Yeah, I think towards the bottom there should be.
Yeah, right here.
Oh, here you go.
Yeah, this is where you can choose. Okay.
Yeah, you can do the same online. It's got hundreds of them, but I need to get to it. Not sure what this thing is. Let me try and run and see whether it's up. Okay, I think it's working. All right. There you go. All right. So here the model, the program is asking to enter your sequence that to clarify, right? That's the code right here. So I'm going to go on. Let me see. I was on Amazon. Not this one. You know what? I'm just go down. So we can pick anything here. Amazon reviews. So for example, we want to, if we have an application, to check whether this review is positive, negative, or neutral. So we're going to pass this response, the user response or feedback, into our text here. So we send this to our LLM, and it spits out that this is a neutral feedback. Okay, we can try. Well, I have to improve this program instead of, going to the next next task. So let's do the next task. Let's take some text to summarize. So let me see. We can do news. So we're picking any, let me pick something neutral. So we're picking text from this this article, right? So we want to summarize this text. So we put that here in our text box. And then it just gave us the summary. And it looks like it's super fast now. It's caught up. We can start again and do a different review. Let me look for, that's my Amazon. Look for something negative here. Okay, so let's pick this. So the first one we did was a neutral feedback. Let's try this. Come on. So why? Still stuck in there. Probably know what it is. It's trying to recreate the model again. So once this code is improved, it should handle that. I'm rerunning the program, and it's trying to recreate the LLM again. So I think that's why we're getting a performance hit.
So this looks like there's some practical application in terms of, say you want to make sure that reviews on a website, are not harmful or anything like that. You could potentially not necessarily hide, positive or negative or neutral, but maybe training the model to see whether particular reviews are not adhering to the company policies, perhaps. Making sure that the reviews are actually good, actually reviews instead of like harmful messages. So you could potentially use this, perhaps.
Yeah. On top of that, for example, same example, right? You have customers, providing reviews on your products, but what you want to do is to improve your ratings, right? So we can put in this LLM to determine which reviews are like negative, and then you send that as a report to your managers. So once they get that list, they can, go back and reach out to their customer and try to resolve issues with them, and eventually that should improve.
The product.
So yeah, they are different, a whole lot of business use cases. I'm not sure what is going on with this server here. Okay, so it looks like something worked this time. So let's try again. And for summarization, you can have an application where you're scraping text from website and then summarizing those texts and using the summarized text for your use. So there are a whole bunch of use cases for these things. Okay, so now we have, so we have our negative review here. So it says negative, right? And it's 1 star. So, it refreshed. That's fine. Oh, this one. It's 1 star here, so it's definitely negative. And then you can grab another content somewhere. Another content. Probably this time we can review the output of the summary and see whether it makes sense. So this talks about some UGBA generated 1 sec in 9 games. So, and in the output, say UGBA had no guaranteed money left in his deal and a 17.7 million cap hit. So it looks like it's doing the right summarization, right? Okay. Yeah, so that was the 2 examples from those 2 models. Of course, this is not production ready. You have to handle errors and limit parameters and all that. So, but this is a quick prototype to understand how to use the models. Any questions? If not, Where are we here? So at this point, we've gone through all that. I think we are at the point to talk about RAG. Okay, so let's take an example. Let's say you pick up a model, and then it's a pre-trained model, and even on top of that, you fine-tune it with a specific data set, and then you put that in production. Now, tomorrow or in future, that model has only seen a specific data set that you fine-tune or train on. So when you ask future things about your domain, the model will not give you the right answers. So that's where hallucination comes in play. So in order to resolve that, there's this Retrieval-Augmented Generation approach where you have what's it called? Vertex database. Let me see. Make sure I'm using the right word here. Give me a second. Do we have the architecture in here? I don't think we do.
No, the architecture is not on this one.
Okay. I should have a local copy somewhere. Is this big enough?
Yep.
All right. So let's just focus on the architecture here. So for an existing company, companies already have their websites, company portal that, behind that set of databases and load balancers and all that. So with the existing database, this is the area where the existing architecture of a company sits, right? Now comes the LLM. They want to implement LLM as part of this existing architecture. So for the existing architecture, the website, the portal is sending data to a data storage, a database, maybe relational, it may be vector database. And then they pull in stuff from there. They may even already have an older chatbot that they want to upgrade to, an LLM chatbot. So with that, the way to look at this is first have a vector database. There are different companies offering vector databases. I think I listed about 5 of them here somewhere. Otherwise, it's in the notes. So we have Phase. Okay. All right. So there are different companies or vector databases that you can use. The Milvus, the Anoi, Pinecone. We are using Phase for this presentation. And there's Elasticsearch with plugins and others. So, and then there's a common one called ChromaDB, and that's a good one to use as well. But for now, we're using the Phase here database. So you have to have a vector database because it helps with similarity search that we're going to talk about soon. So what happens is your model, your LLM is sitting here, right? Which is either a pre-trained LLM or even a fine-tuned one. But it's going to get outdated very soon, right? Because things are changing. You're getting more new information in your company. So what a typical example will be for you to ingest that new sources of data into the vector database, right? So in order to do that, you have to run those information. So it can be PDFs, right? You have a bunch of PDFs, you have a bunch of website text or text from websites, CSV documents. So you can pass all those data through an embedding model, and this model will convert or chunk out those texts and store them in the vector database as a knowledge base. Now, once you have that, and a user, assuming you have a new chatbot, right? A user queries, communicates through the chatbot, sends a text, a sentence. That sentence is passed through what we call the relevancy model. So there's another model that is used for searching the vector database for. So the text is also embedded, right? It changes the text into numbers and then compares that input text to what is stored in the database, in the vector database. Now, the results of that is in a form of a text that you append or form with the query, the initial query. So you take the initial query, the context is this arrow is showing differently, it should be opposite. So the query plus the context, which is the results from this search, from this retrieval search, plus your prompt template if you're using a template. And then you pass this, a combination of text through the LLM. And then LLM is, as we saw, is the transformer model that goes through tokenization, embeddings, and retrieval. And then it gives you the output. So the output may be on the results from his query on the chatbot. So the RAG is the approach of having this retrieval model, the embedding model, ingesting data into the vector database and retrieving it and forming this, pushing it through the LLM for results. So you're going to see different architectures. RAG architectures mostly will follow this concept. What else? Any questions on this architecture? Okay. It's simple enough. Yeah. So as far as demo, we're going to look at an example where we pass a query to the LLM with no context, right? So the context here will be blank. So we only pass in a query and a template. And then we're going to review the output results. And then another example to use the knowledge from the vector database. So that knowledge will be in the form of a context. And then we're going to compare pass it through the LLM and then compare these two results and see what, which results produces relevant output. In future, I'm moving on to add multiple sources of data, data sources. So right now, today, we only have one data source, which is a PDF that we're going to embed and store in the vector database. But in future, you can have the PDF, CSV, you can scrape the web for content and a whole bunch of data that you can push into the vector database.
Kofi, maybe I have a quick question.
Sure.
Maybe can you expand on why, on the advantage of using a vector database versus a regular SQL database to like query knowledge?
Yeah, for SQL, normally you send your query and then I don't remember the search. I think it's called something pattern. Sorry, but basically, you're sending a text and it's searching for that text within the database. So it's a specific kind of search or retrieval. But for the vector is changing the text into numbers. And what the relevancy model does is to be able to do like a cosine, right? For the input text that you sent it, how similar is that input to the data in the vector? You cannot achieve that with a relational database. So that is why that is the advantage of using the vector database compared to relational. If that makes sense.
Yeah. So in a way, for SQL, the data has to be like structured, and then we know how to run the SQL query. But for vector databases, it's kind of like ad hoc, regardless of the data.
Yeah, that's a good explanation.
Yeah.
Can we use a vector database for like a traditional application?
Yes, definitely. I mean, vector, MongoDB, and I think Amazon has one called DynamoDB or something. So, yeah, so vector database has been around for years and being used in applications.
So it's like it's another version of like a NoSQL database or something. Can we consider like a vector database as being like a NoSQL database?
Ben, do you know the answer?
See?
Yeah. So
sorry,
yes.
I was mute. Yes, in a way, yes, because there's no predefined schema.
Yep.
So in that sense, can be thought of as a NoSQL database. Actually, as a matter of fact, there are a lot of well-known NoSQL databases that added vector features. For example, MongoDB, in addition to storing JSON documents, you can also store like vectors and search on that. So, yeah.
And even Oracle has come up with a vector DB on top of the the Oracle database. And as explained, this data is unstructured, right? So you just chunking the data and pushing it into the vector database. But if we were using relational, you have to structure that data, right? You have to put them into different fields and all that. But in this, you don't do that. You take that document, then you split the document, and just pushes it to the database and it stores it.
Okay, thank you.
All right.
Sophie, one question. I apologize if you already mentioned that, but I wanted to kind of like ask, why would a company, I guess, use a RAG? Why would a company kind of like not use the generative, the LLMs right away? Why would a company want to use the RAG? Like, what's the advantage, I suppose?
Yeah. So some of the pre-trained models, depending on your use case, will be perfect even without fine-tuning it, right? So you can just pick that model and just use it. So in that case, you don't need all this RAG stuff. You just need a simple, you have the model and then you feed in queries to it and it returns. And the output you have to compare to the expectation, right? So you go through testing and you compare to the expectation. So if it's good enough, then you don't have to use RAG. Then there's other scenarios where you pick the model, the LLM model, you pass queries to it, and then the response, because the LLM is pre-trained on large data set like Wikipedia, the internet, right? So actually we're going to see an example when we run the programs. The response may be talking about something different. You mention a word in your query, and then it does its own thing and produce hallucinate. So in that case, the pre-trained model will not be good for you, right? So you have to look at trying to apply prompt engineering. So prompt engineering, when you do that, pass the model examples to train it, that may be the resulting model that meets your use case. So then in certain cases, even prompt engineering will not give you the results that you want, the right results, the relevant results. In that case, your company have to come up with a data set, a labeled data set, right? So you have a bunch of queries, let's say 5,000 or 1,000 queries. Queries, I mean prompts. And then you let the people, the domain expert, goes through those prompts to give their response to those prompts. Humans doing that. Now you pass the prompts with the human labels through the LLM and train it, and train the LLM to change its weights to be able to answer query prompts the way similar to what the humans, your company have provided it. So mostly fine-tuning, really improves the performance of the LLM. But in sorry, I'm giving you long answer. But in other cases, you've applied for prompt engineering, fine tuning. It's all good. You push to production. If you don't use RAG, anytime there's new, let's say, new data for your company, your model will start hallucinating, will start producing incorrect results. So in that case, you have to have your team, your development team, go back and retrain the model and then push it to production. And it's going to go on over and over for many years. Now, what the RAG does is when you set it up this way, all you have to do is to ingest the data into the vector database, and that's it. So you get new data in your company, you just ingest it, and then the system will take care of itself.
Got it.
I'm sorry for the long explanation.
No,
I just wanted. Go ahead.
No, go ahead, Ben. I
just wanted to mention it in a slightly different way. So imagine the RAG architecture is like I mean, with the let's imagine for a second that the LLM is like a student that knows how to read, how to think, and things like that. And then that student has to go and take an exam, to answer properly for a given company, right? And if the student doesn't take the time to read the book before the exam, the student is going to start making up answers that don't make any sense. So in this architecture here with the vector database, it's as if the vector database is that book that the student was supposed to read, and then we force it to read it before providing an answer. Because the information that's if you want, the knowledge that's stored in the LLM is in a similar format as what is stored into the vector database. So the program can easily traverse it and then have more context to build up the answers.
Yep. Thank you.
Yep. And I think that the human mind, one example could be having a resume, right? So when there's a new job opportunity, there may be some skill sets that you don't have, but you can quickly skill up in 3 days, right? So once you apply, you go and do your learning. And then, so that's an example of, fine-tuning your model over and over again when you have new data. But that is a longer process, right? Because you have to have a development team in place. But for this, once it's set up, it can be set up in a way where there'll be a repository, right, where you dump in files. So once you dump in files, you have programs to just load the stuff here, and then everything works. Of course, as a company, you still have to test each of the cycles, each of the data that you dump into that repository. You have to do some preliminary tests, but it's not going to be involving just like us in not having RAG approach. All right. So let's see RAG in motion here. Oh, okay, I already have it here. So this is the program that I created. These are the installed applications that you have to install: the torch transformers and the phase vector database, some PDF tools. We are not, Streamlit didn't work well in AWS, so we're not using Streamlit. And then the LangChain, you have to install the LangChain. So these are the 3 core libraries that we saw on the LangChain website. And then you import all those libraries. And then within the code here, this is the file that we're going to ingest into the vector database. Let's see where the file is. Something is not. Looks like this thing is frozen or something. Yeah. I want to refresh it. Anyways, it's going to find the file. I was going to open the file. Should have a local copy somewhere. So there's a local copy. This is just a story that I asked ChatGPT to write about this young girl called Daisy in the countryside. Right.
So, can you bump up the font a little bit?
I'm sorry.
Oh.
So there's the story that I've been written for, Daisy's country misadvantages. So I'm going to ingest this data into the vector database, and then with that we can. So that's the file that we're going to ingest, and then the PDF loader. You have to get a PDF loader. Excuse me. So it's a PDF. So we're going to use the PDF loader, and then we pass in the file in, right? So we're going to get a loader and then load the PDF pages, and then split it, load that document, and then split it into pages. So once you get the pages, you can output the pages and see how it looks like. And then we're using the recursive character text splitter. So this is the library that will split. So for each of the pages is going to chunk it based on the sizes that we've provided here. So once it does the chunking, we have the text chunks in this variable here. And then actually the chunking is down here. So the split documents. So it splits the document into that, and then you can print and see how the chunks looks like. Now, so we have the document split, right, or chunked into this variable here, and we're passing that into the phase vertex database. So we do that, and then we call the Hugging Face embedding model, and this is the model name. So when you look at the architecture here, this embedding model. So we're using a Hugging Face embedding model, and then we also getting the retriever. Retriever is the model here. So this is what will get the query from the user, and then does a similarity cosine search from the vector database, and then return the results. So that's the retriever here. So our use case here is for summarization. We're using the Facebook BART large CNN. We're doing summarization, so we get a pipeline. And here is the LLM. So we already have the pipeline, the regular pipeline, but we're wrapping that around the Hugging Face pipeline to get the LLM. And then we form our template, our prompt template. So we want to summarize the story about Daisy. And then this is the context variable in our template. So this variable will be replaced by the results of the retrieval here. So it's the query plus context. So once there's a match from the vector database, that context, that result is being appended to your prompt. And then we pass the prompt. So this is the LLM chain. So you can this is a LLM chain, I think from LangChain. Where is that? Yeah, from LangChain. So there we get an LLM chain. So we pass in the model and then the prompt. So this is the querying of the LLM, right? The Facebook Barla CNN without RAG, right? When you look at the example here, I'm setting, this is the main function. I'm setting the context to blank, which means this here will be blank for this call. So this is an example without RAG. And then we have another example combining the LLM plus the retriever for RAG development. So here we have the LLM chain here, right? And on top of that, we pass in the context, the result from the retriever, and then we pass in through our question, our prompt from the command line, not command line, from online, for example. So when you type in what you're trying to, when you type in your prompt, it's going to take the question and then invoke the RAG chain. Here we invoking a chain, but it's without the RAG, right? It's without the retriever or the context. Trust me, this code works. Excuse me. So let me go and try and run this thing here. Hopefully all those things have been installed. Looks like it's run the cell. So again, see how quick the results came out. So this is what is happening. So here, as you can see here, once we got the document split, we have a print here that says pages from the loader. All right, so these are all the pages from the loader. So page 1 this is what has been stored as page 1, and then maybe page 2, page 3, all the way down through the document. I can look for, search for this here. Yeah. Why is this thing restarting again? Okay, there you go. All right, so this is without. So this is the page, and then it also passes some metadata, basically stating what the input document is. So in this case, it's a PDF. So that's that. And then when we came down to, so we put that in the database. And then there's another print. Hold on. So that was the first one. We just displayed. And then, no, the first one is just the pages, right? And then the second print is pages from the loader. It's confusing because I should have said something different. This is the split. No one's changing it now, but this the second text here is when the document, the above document was split. So as you can see, it's got split into different documents. So the content 1, this is for, so it's split it into different documents, document, all the way through. So this is what is going to be stored as different chunks into the vector database. So this is what we're doing here. And now, after that, our prompt is, question is, we want to summarize a text, right? So that's our use case. Since we are calling the LLM without the RAG with this prompt, I'm going to pass the same thing to the RAG version of it. That way we can compare the outputs, right? So this prompt here is without a context. And I want to use the same prompt for the RAG. So I put that in here and I hit enter. All right. So with the prompt, summarize the story about Daisy, and remember the document, how did it open at? Well, the PDF that we loaded to the vector database, it's actually here. It's a story about Daisy's country misadvantages. So I asked the LLM to give me a summary of that story about Daisy, and this is the response he gave. He's talking about some CNN, and the only thing here is Daisy, right? So this means that the pre-trained LLM here, where is that? This pre-trained LLM does not have any information about the story of Daisy. But once we applied the RAG, we were able to get these results here. Daisy had a peculiar talent for finding herself in the most absurd situations. Armed with a picnic, Daisy said, so once you go through this text, you'll know that this is a good response, and it's relevant to the prompt that was passed to it, to the LLM. Any questions here?
So in the first part, there's definitely some hallucinations, or it responded the best it could, basically, but it wasn't the right answer.
That's correct. So in the question that you asked earlier, in order to fix this, you have to train, you have to fine tune or even do prompt engineering to get the LLM producing something close to this. But if you have RAG, you just push the data source into the vector database, and then it's able to use the context from the vector database to help produce high quality results. And again, it's not just PDF. LangChain, when you go on LangChain website, when you go to the model.io, is it model.io output process? I believe. Retrievals. Yeah, there's a lot of different document loaders, right? They have PDF, they have HTML websites, they have CSV, whole bunch of them. So you can create an application that can handle all these input data.
Yeah, so basically, one of the key elements is that, I mean, for all of those AI systems or applications, is how, I mean, depending on the use case, we are able to turn things into a vector. That's like the key part. You know, so tomorrow, if someone is working with audio, if they come up with a good way that preserves as much information as possible, you know, to turn that audio into a vector, then some wonderful things can be built out of that. You know, for example.
Yeah, so it's a powerful frame and approach. We have some few minutes. Any more questions?
No, I'm not seeing anything in the chat.
Okay.
I have a question.
Sure.
What are some of the best effective ways to compare different embedding models, like for any given use case?
Well, you can start from Hugging Face. I know we use the Hugging Face model. There should be other models out there. And then you have to set up a testing process, right, to pass through some data sets, passing data sets for one model, and then do your evaluation, and then pass the same data through a different embedding model, do your evaluation, and then you can you can compare that way. I'm not sure whether that's what you're looking for.
It is. I was trying to see if there's a way to a way to maybe slim down the number of options for a given use case without just having to, pick, run, try again, since that takes a bit of time.
Are you talking about the LLM model itself or the embedding models?
Well, I'm thinking of it as an entire like process and pipeline, right? So just trying to optimize particular pieces of it, but specifically the embedding model. Yes.
Okay. Yeah, what I can think of right now is if you want to test and compare, is to run data sets through each of the models and then review the outputs. Well, the embedding output will be in a form of embeddings, numbers. So you have to have a way to decode that back into well, doesn't even make sense at that point. Ben, do you have any?
Yes, I'll put a link in the chat as well.
Okay.
So, like when we are discussing embedding, there's this aspect of like having the ability to turn the input data into a vector, and those vectors, they actually have a length, right? So I think the one that was used for the longest time for OpenAI had the length of 1536. So 1536 items into one vector. And recently they released some new ones that are double the size. There are also some smaller ones, right? I think it all depends on the information that you want to process. Like I give you like it's not like an LLM or anything, but when I was taking a class, one of my project was to analyze audio data, right? And at first I was just trying to use the the sound levels. Okay, I'm not gonna give too much details about that, but when there's an audio file, like what makes up the sound is actually a bunch of numbers compressed together, right? At first, I was trying to use that to do my analysis, and I had very, very poor results, because the way I was processing it, it was not able to capture a lot of information, right? So instead, what I ended up doing is to take a picture, if you want, of the audio wave, and then with the colors and everything, my model was able to pick up some very fine details. So from that you can imagine that based on the data, the nature of the data you are studying, longer models might be appropriate in some use cases where fine details matter, and then smaller vectors might be used for like simpler data, if you want. But I think it's something that needs to be tried. It's not always possible to to decide that, okay, this is the one that's going to work best. So.
Okay, great. That was really helpful. Thank you.
Any more questions?
What is your personal favorite model? I've been using Mistral, and that it seems like that's become kind of my favorite. But what is your favorite? What's your personal one that you use on a regular basis?
I just started using these models, but currently I'm using Llama. But the point is, each of the models have there are different use cases for each of the models. So normally I'll start with the with the bigger companies like models from Google or Facebook, and then go down from there. Because as you see from Hugging Face, just the text generation, there are 50,000 models, right?
Yeah.
So there's no way you can sit and dig through that. So I start from the top, the good household names, and then go down from there.
Yeah. Thank you.
Mm.
Yeah,
Yeah.
so yeah, go on.
No, I was just asking if there were other questions or comments.
I was gonna ask a question for Kofi. So, Kofi, do you see this maybe like the architecture you presented? Do you see it as having the ability to replace a lot of tedious work, like for back office work in the future?
Yes, definitely. The example that we took, right? The semantic analysis, the classification. And I mean, currently Amazon has the rating is even. I think it's going to even replace the ratings, right? So whatever they're doing today to get those 5 stars, 1 star, I'm sure it's a tedious way of coming up with, the way it's implemented. But this is a simple, this is the text generation. Yeah. So without the other, so let's say I take out this code, right, and then some of these off. It's only about 20 lines of code to do the classification, and it does it very well, right? So of course there are different scenarios within company landscape where LLMs will replace a lot of processes and even introduce new ones in, right? So another example will be, companies have meetings all the time, and then they record these meetings. Now, how do you send summaries? Because I remember, after the meeting, you have to spend hours to document and summarize everything and send it to everybody on the meeting list, right? But now you can create a process where you can just dump the audio into a repository and then transcribe the audio and then into text and then send the text to the LLM to do the summarization. So with the right prompt approach or setup, once it's set up, once you dump in the audio file, in a couple of seconds you have your summary, and then you can send it out. And now you have agents that can even send emails, right? So there's a lot of things within our companies that will be replaced, or that LLM will help.
On the flip side of that, Kofi, you mentioned something about, when you were talking about people manually creating the questions and then actually giving the answers so that you can feed it to the RAG. That is manual process, right?
Oh, yes. Mm-hmm.
So do you want to maybe talk a little bit about that, like in terms of like, as much as the beauty of all these models and doing all that work, there's still a little bit of manual process if you want to, let's say, fine tune or fine tune your model to your specifications. So.
Yes, it's definitely there's a lot of resources that you can put into fine tuning, especially if you want to add on top the RHLF or something. Is basically is what we talked about earlier, because companies know in certain domains they know exactly what a response should be for a particular or for a set of prompts, right? So in order to really train these models, you have to spend the time, different stakeholders within a company, for them to go through this prompt list to make sure that the labels that is being assigned to this prompt are correct. Because if you don't feed the LLM, if you don't train the LLM on quality data, then you definitely not going to get quality results. So there's tons of resources that or time that you need to spend labeling these prompts, and then eventually training the LLM, and then finally deploying that.
Yeah. So an example that I can think of is kind of like, let's say you have a manual, like an office manual for a particular procedure. That manual has, the details about that particular procedure for a particular, the answers to a particular procedure, right, or steps. So in order to feed that to the model and for the model to give you the exact response when you ask the question, then you have to manually basically attend the question or the procedure, and then someone would actually have to type in the steps, for example, right? So yeah, I think that there's definitely some manual process.
Okay.
Yeah, I have an example also.
Okay.
That manual process you mentioned, sometimes it can be hidden in plain sight. So I'm sure a lot of us here are familiar with GitHub Copilot. That helps us write code, with nice auto completions and all that. So in part, the way that the model is trained comes from the Git commits. Because when we push code to Git, not only we have code, but we have text as well for the Git message, that explains a little bit what this new code is doing, right? So in a way, we are labeling the code that we push to GitHub, right? So they use this information, they leverage this information to, to enhance their training. That way, when it comes to actually writing code, we can type a small comment with our intent, and then it can more easily infer what we are looking for and then generate some code. So sometimes it can be hidden. It doesn't always have to be like hard work.
Yeah. I think even when you go to a website and they ask you to find a cat or find stairs or find, they show you an image and then they tell you to find something in the image. That also, in essence, you helping them label data set in a way. So.
Hello. Yeah. So I have more like a suggestion more than a question. So can you guys hear me?
Yeah, go ahead.
So I learned a lot with these meetups, but I don't know how to put all these things together, right? And some of the concepts, they're still very abstract to me. So is there a way we can take like a use case from A to Z, like we take something from scratch? The company is trying to do something, right? And we go step by step. Is it possible to do that?
You mean as a talk?
like we take a use case, right? Then we go, for instance, a company is trying to integrate AI into the operations or something like that. So we can use a tool, we can explain why we're using it, we can ask questions, because right now it's a little bit abstract, right? To me, I don't know for the other people, but for me, it's very abstract.
Yeah, I can kind of concur with that. It would be cool to do that because, like, so I'm coming from a background where I'm doing mostly like web applications and stuff like that, and learning how to integrate that in, or how that can benefit. Like, I know and use some things to increase my workflow, but like actual use cases.
If it's possible, if you want, I can come up with a use case, like a real company is trying to implement something. So we can go over DevOps, we can go over everything, why we decide to go this route, why this tool is better than the others, how do we test them, how we integrate, how does it look like from a user perspective, how it's going to impact, how do we test it, deployment, production. If you ask me to deploy right now, like AI, I don't even know where to start.
Yeah.
See? So it's just a suggestion, but
yeah. So that will be a future training session, right? So we can organize something like that.
Yeah, no, I'm pretty sure it's gonna take weeks to be able to go from A to Z. It's just like,
and it may not be just one Saturday, right? So we may need two sessions to get through all that.
Yeah,
it's gonna be more than that.
Absolutely. I don't think it was like a suggestion. It's like, all right, right now, let's come up with a use case.
No, I'm not talking about right now. Well, I'm talking more about how we can do the sessions. So
well, we have access. You guys have access to the Discord, right? So we can get started on, like, for example, trying to figure out what that use case might look like, and then from there, decide on whether it will require multiple talks, how each talk could be, and what we want to get out of each talk, and then who's going to work on which part, things
exactly.
Like
and and we have different expertise, right? So someone can present, someone can be like, okay, I'll take care of the DevOps aspect of it. This is why I decided to go with this cloud provider, use these tools, and we can ask questions, like, okay, we can challenge and ask questions too, right?
Okay. Yeah, I think that definitely could be a nice way to put it all together, because it's right now it's a little disparate, and you don't necessarily know how to, like you said, right? How do you even put this into production? That's another beast on its own. Like, that's machine learning engineering, right? So ML ops and things like that. So
and there are a lot of moving parts, right? You have Hugging Face, you have LangChain, so
So I think this is a great suggestion, because like sometimes it's nice to learn, like you said, but there's also something called decision fatigue. With so many options, so many ways to do things, so many resources, so it will be helpful to like streamline the if you want the learning for all of those things combined.
So I think Ben put in the chat the Discord link. So I would highly recommend you join, so we can start discussing how to go about this. Especially first of all, finding the use case, right, and go from there.
Okay. Correct.
And figure out who's gonna, like all the folks that want to help, because it will definitely be great to see that.
Okay, no problem. I will join the Discord, and I definitely have several use cases that I can suggest. So okay. As usual, I really appreciate what you guys doing for us. So.
Yeah, thanks for definitely coming up.
So
Go ahead, Kofi.
no, I was just saying welcome.
So all right, we're at 11:34. We usually try to do it within 2 hours. Are there any other questions, comments?
No.
We'll be sending out the next.
I have a question. It's not really a question. Like I have a Kofi mentioned earlier, like he's doing some teaching in Python. So I don't know if he's still doing that. I would like to join.
It's going to be on this platform.
Okay.
Yeah, if we, so yeah, Aziz and Ben will manage that.
Okay. So are you saying you want to teach a Python class soon? Is that what you're saying?
I can.
Okay. All right. We'll figure out timing and all. So
Yeah,
Okay.
so we can use that for the use case.
Yeah, we can build something from Python and then move
yeah,
on.
Exactly.
So yeah.
all right.
Yeah. But first, you need to know the fundamentals, right?
Yep. Okay. So we'll send out the meetup schedule for the one coming up in 2 weeks, and we hope to see you there. And I thank you for all the ones that joined today, the newcomers. We hope that again, as you see Kofi today presented, if you want to present on any topic, you're welcome. And then we can kind of like slot you in and help you with the process and all. So any topics is welcome. We all kind of, as you see, learning from each other and collaborating. Thank you, Kofi. Thank you. We really appreciate that. That was a really good talk. Yeah.
Thank you, Kofi.
You're welcome.
Yeah.
Thanks, everyone.
All right. Thanks.
Yeah.
Cheers.
Bye.